Hello there, amazing students, amazing people, and all lovers of chemistry out there. I'm super excited to be back here on this episode of Question for the Day. Now, on the screen right now, we have a question that's asking us saying a sample of gas occupies 300 centimeter cube at 27 degrees Celsius and 100 kilopascals. What volume will it occupy at 47 degrees Celsius and 120 kilopascals, assuming the amount of gas remains the same? So first things first, let's write out the values of all the variables that they've given to us. So the first thing they tell us is that the gas occupies 300 centimeter cube. That is the first volume, which is V1, is 300 centimeter cube. The next thing they tell us is that it occupies that volume at 27 degrees Celsius. So the first temperature T1 will now be 27 degrees Celsius. The next thing they told us is that it occupies that at a pressure of 100 kilopascals. So the first pressure P1 will be equal to 100 kPa. Now, what are they asking us to do? They said, what volume will it occupy? What volume will it occupy tells us that V2 will now be unknown. So now they're saying what volume will it occupy at 47 degrees Celsius. 47 degrees Celsius tells us that the second temperature T2 is 47 degrees Celsius and 120 kilopascals. That is, the second pressure P2 is 120 kPa. Now, they said what volume will it occupy, assuming the amount of gas remains the same. So at this point, now that we have all our variables, the next question to ask is there any formula that relates all these things together? Yes, there is, and that is the general or the combined gas equation. This is the equation that combines the Boyle's law and the Charles law, and that equation says P1 V1 all over T1 is equal to P2 V2 all over T2. So now let's go ahead and impute our variables and solve this question. P1 over here is 100 kilopascals multiplied by V1. V1 is 300 centimeter cube divided by T1. Now, when it comes to the general gas equation, we do not use temperature in degrees Celsius. We convert it to Kelvin. And to convert to Kelvin, if you want to convert from degrees Celsius to degrees Kelvin, what you simply do is to add 273. So now that we have 27 degrees Celsius over here, we simply say plus 273, which will give us 300 degrees Kelvin. So now that we have that, T1 over here is 300. This is equal to P2 over here is 120 kilopascals multiplied by V2. V2 is unknown, so we just simply put V2 over here. We can put X, we can put V2, whichever one we choose. But in this case, we're using V2 directly. Now, T2, which is the second temperature, over here we have 47 degrees Celsius. So to convert that to Kelvin, we say plus 273. 47 plus 273. Let's do that real quickly. 0 carry 1. 7 plus 4 gives us 11 plus 1. That's 12. 2 carry 1. This is 320 degrees Kelvin. So now that we've done that, let's go ahead and do some math. 100 multiplied by 300, that gives us 30,000. 30,000 divided by 300 is equal to 120 V2 divided by 320. So doing that, we can cross multiply. When we cross multiply, it becomes 3 or 30,000, I beg your pardon, times 320 is equal to 300 times 120 V2. So when we do all of that, just give me a moment so I can erase a few things so we'll have space to write some other things. So now when we do that, we have 30,000 multiplied by 320. 30,000 multiplied by 320 gives us 9.6 million. So we have 9,600,000 equal to 300 multiplied by 120. 300 multiplied by 120, that gives us 36,000 V2. Now, since we're looking for V2, we just simply divide both sides by 36,000. So this cancels this. 9.6 million divided by 36,000. Let's do that very quickly. Let me punch my calculator. 9.6 million divided by 36,000. That gives us 266.667 centimeter cube, because the question says what volume, and in this case our volume is in centimeter cube. So now that we've calculated it, our final answer is the gas will occupy 266.667 centimeter cube at a temperature of 47 degrees Celsius and 120 kilopascals. Thank you for sticking around to the end of this video. I trust it was educative enough. Please like, share, and subscribe, and I'll see you in the next one.